So welcome once again. This is the lecture number 4 of the deep learning course. And in this particular session, we are going to see that what are the evaluation parameter means if you have if you have a data and on that data you actually develop a model, how good this particular model is. Many of the time you want to find out that how good this particular model is, because if there are multiple models, because on the same data you have the option to have multiple model. So which model you are going to select out of this? Which model you are going to select? You are going to select the item which has the higher accuracy. Most of the time you want to select the item which has the you want to select that particular model which has the highest accuracy. However, in the today's class we are also going to see that only talking about the accuracy is not a good idea, that we are also going to see in this particular class. So these things are today's matter, that I'm going to see that what are the important evaluation parameters that we actually want to find out and what they signifies, what is their importance. We would also see that what is the optimization. Optimization means sometime we want to find out the better result, and actually we are going to do when we are going to train the model. What do I mean by training the model? Changing the parameter. Why we change the parameter? To reduce the error, means we want to, and by this what we are doing? We are doing optimization. So ultimately, what is the optimization? What is the theory behind that? We are going to see something related to that into the today's class. So this is the agenda for today's class. Let us start our discussion. So I would start my discussion by telling you this particular important thing, that what happens now if we have a database. Let's assume that you have a database and you want to learn from this database. Learning means what? You want to develop a model, and if you use all these data, and let's assume that you are ready with the model, you have learned this particular model. So definitely your model is going to be very good on this particular data. What does it mean? Learning means that your model performance of your model is very good on this particular data. But whether you want to use your model on this data, answer is no, because on this data, what is the right answer? It is already given. So there is no sense that you are going to use this thing to find out anything useful on this particular data. Your objective would be that you apply this thing on some unseen data, the data that is new and that is not shown to you. You want to apply your model on this particular new data. But if I give you this data and I ask you for a model, where is this new data? New data is not with you. Nobody has given this new data to you. So there is a big problem, that new data is not there. Then how can you find out that if multiple models are possible, which model is going to be better? So you know that what is the standard solution? Standard solution is this, that since this data is not available, I am going to take part of this particular data and I am going to put this as a separate part. What I'm telling? I'm telling that this data, it is a standard thing most of the time, you know that. Once again, this D has two parts, this and this. I'm going to say that it is, you consider this database having two parts, and one part I'm going to reserve, and I'm not going to show this particular part for the training. I am going to use only this part for the model training. Understand? So this is a standard practice where whenever a data is given to you, you divide this into two parts, and one you say that it is training and another is the test partition. And if you want to train the model, you are going to only use this particular part. So if the data is there, how much data you should put into the training and test? Mostly, generally, what we do, that 80% of data is into the training and 20% into the testing. But nowadays, when actually we are into the era of deep learning, then the huge amount of data is needed to train these kind of models. If more data is needed to train this kind of model, so then what I wanted to tell, that if more data is if lot of data is needed to train these models, so let's assume that later lot of data is available. If lot of data is available to you, then you can say that even 1% data is significant enough for the testing. Okay, then you can say that 99% data I'm going to train and 1% for the testing. Assuming this 1% is not a small number, it is going to be a considerable size. So this is the one thing that we wanted to bring in front of you. Mostly, I think that you may be knowing, but just for the sake of completeness, I brought this particular thing, that data is divided into training and testing part. And for the model, for the purpose of understanding of the model only sees this particular portion of the data. Complete data is not shown to this thing, and we understand that this particular part is there, but it is not used for the training. Okay. Now, as I told you that if you are going to use this particular for the training thing for the training, so multiple models are possible. Multiple kind of mathematical models are possible that you can utilize for your model development. For example, I can just give you some example. For example, SVM or decision tree or neural network or whatever. Different kind of models are possible. If multiple models you have trained, which model you are going to use, which one you should use, the as few minutes back we have talked about the item, the particular model which has the highest accuracy. I want to use that thing, okay, because multiple things are possible. So I would like to use the most effective one. So if you actually want to find out that what is the performance of your this particular model, okay, once again, what is the performance of this particular model? So on this data, which data? On this particular part, 1 minute. On this particular part, I want to see, let me just remove everything else and just show you this particular part only. If I just bring your focus to the training part, so you would be agreeing with me that it has two parts. One is the X part and another is the Y part. Okay, Y part is that something that has been given to you. So and we have also seen in the last class that if you are using this particular data to train something, you are ultimately going to reach to some hypothesis, and on this hypothesis, if you supply the X, your value should be Y. Your value should be Y. Whether you would be able to find out that the value is going to be Y, please note, whatever we have seen till now would be only true if my model is sufficiently strong, or we know many things about the data. Most of the time the data would not be like that it is linearly separable and you have to find out the line. Most of the time it is not going to be the case. Let me just quickly give you an example. For example, let's assume that this data, let's assume that here are the positive things, okay, and here are the negative things. So can you develop a model? Okay, you can say that, sir, it's very easy, this data is very easy, I can draw a line like this. Yes, because this data was linearly separable. But if I say that the data is like this, if I say that here are few negative points and here are few positive points, can you also draw now the line? Answer is no. Now you cannot draw the lines. So if the data is not linearly separable, and which is actually the most likely case going to be when you are given a problem, then your accuracy is not going to be 100%. Your things are not going to be perfectly fine. So you want to be best. Okay, if some model is going to have the accuracy 70%, another model could have the accuracy of 90%, another model could have the accuracy of the 92%. So you are going to select the one which is going to be more close. You are going to give me the hypothesis which is more close to the target function. To the target function means the guard function that you actually know, because we understand that Y is coming from the guard function. Okay, so how can we define that what is the closeness, how close we are? So in terms of the classification, if you are going to do a classification problem, so if some item is going to be given to you X, then you see that what is your model, what your model is telling. Model is going to tell you, because model is a hypothesis, so hypothesis of X, and you say that what is the value of what is the actual value. Using these two things, you actually want to find out some quantity that is called the loss, and this loss is going to be can be defined using this function, that what you want. Both the values should be same. If they are not same, you say that there is a loss. If they are same, you say that I'm okay, there is no loss. Loss means problem. You say that there is no problem. So on the complete data for database, for every item you are going to find out this value. So by this you can find out that what is the total loss on my data, classification loss. You want this value to be lesser or higher? Can you type less or high? You want this value to be higher or lesser? You want this value to be lesser because it's a loss. You want loss to be lesser. Similarly, in case of the regression where you want to come up to a particular value, let's assume that this particular problem is such that on the database with the X part there is some y part, and y part is some value. It is not only 0, 1, -1, +1 kind of thing. It is going to be a value. If it is a value, then your hypothesis, the value that is going to be given by your hypothesis and the y, they should be very near. If they are very near, what is the difference between them? Difference between them should be 0. So any value could be higher. So I can say that the difference between these two values, if I take the square of this thing, just square is just to make the things positive, this value should be as small as possible. So I can define the loss in the case of regression using this particular formulation. So if the two values are not same, I can define the loss like this. If the two values are same, the value is ultimately going to be 0 only, but it is just for the sake of writing, it is written that otherwise the value is 0. You know that if the values are same, it is this value, this expression is itself going to be the 0. So if you have developed a model, you want to find out that what is the loss of your particular model, and you want to minimize this particular loss. Make sense? Idea is this, once again, the idea is this, that if your data is given to you, once again, we have multiple number of time I'm telling this, that training data is given to you, and you want to be good on what? The unseen things. Okay, training data is given to you, you want to be good onto the unseen thing. But unseen thing, how can you change your parameter? Let's assume that you come up with some parameter that is very good fitted on this particular thing. So would you like to change this in any way if it is not going to improve the accuracy on your training thing? Okay, because I don't know that how good I am, because ultimately in the theoretical world, you know that this data, this part is not available, the testing part is not available to you, only training part is available to you. So if you have come up with some parameter that is going to be very much suited to your training data, are you going to change it? If it is the best parameter, let's assume that it is going to be the best parameter. So, and it is best parameter for training only. You don't know that what is the effect going to be on the test part. So my question is whether you would be able to, whether you would like to change this parameter? Yes or no? Whether you would like to change? No, you not like, because there is no way that you can do like this. So this particular concept is called the empirical risk minimization, means you are going to minimize the risk. Risk is the loss. Another name for the loss. You are actually going to do the empirical risk minimization. And why you are going to do the empirical risk minimization? You are minimizing the risk or loss on this training data in the hope that it is going to reduce the generalization error. Means for the unseen things, it is going to be make your things better. Whenever you are going to change the parameter here, you are thinking, you are hoping that your things would be better on the unseen thing, but you are not sure about this. Okay, but this is the only thing, this is the maximum that is available to you. Only you can only do this particular thing. You cannot do anything other than this. Make sense? Since the only training data is available, so you can only use this data to change. So this particular concept is called the empirical risk minimization, that if you want to be better, you have to minimize the error over here only, and this is going to lead you to find out the right parameter. Any questions on that? Make sense? Okay, so now I'm going to tell you about some more parameters. Okay, you want to do the empirical risk minimization for what parameter you want to reduce. So let me start by giving an example where I have some kind of similarity measure. I want to find out that how similar two things are. So to explain you, I have a example for you. Okay, everybody ask the question whenever you have a slightest doubt. So let's assume that there is some person, Mr. A, Mr. B, Mr. C, Mr. D, Mr. E. So, or we can say that the first person, this is an item, second person, third subject, fourth subject, fifth subject, and you have taken the photograph of these peoples. So I can say that he have given multiple photographs. So the first photograph, second photograph, third photograph, fifth photo, fourth one, and fifth one. So if I ask that what is this particular photograph, this is the 4_3. Am I right? What is this? This is the 3_2. What is this? This is the 2_4. This is the image. Let me just name it into this way. That let's assume that we have our database of peoples. In this facial images of the peoples are there, and I am going to keep their images. Now you may be thinking that if I take this image and I match this image with this image, how I'm going to match, we will talk later. Right now just think that I'm going to use this thing and match with this thing. And let me just quickly mention this also. So let's assume that A underscore B is the image and C underscore D is another image. These two images I want to match. So you have to find out the feature of the image one. Let me say that this is the image one, this is the image two. I have to find out feature of image one, feature of image two, and then I have to find out some way to find out the similarity between them, and then I'm going to get some score. This is the general procedure. Okay, this is the general procedure. So okay, so what I was telling, that if I want to match this particular image with this particular image, okay, I have to find out the feature from here, I have to find out the feature from here. What do I mean by feature? We will discuss in more detail later. So I want to find out feature from here, feature from here. There should be some matcher that find out that what is the distance between these things, and I can find out the score. Okay, once again, now I'm going to be something more technical. If I use this particular image and match with this particular image, whether I am matching the images of the same person or different person, same or different, same. Okay, if I'm going to match, next question, if I'm going to match this image with this image, am I going to match with the same persons or different person? Here, different. If I am going to match different peoples, then I am going to say it that this score is a imposter score. This score is a imposter score. If I am going to match this person with this person, or this person with this person, or this person with this person, these images when I'm going to match, I'm going to say that I'm matching the same peoples, and therefore this matching is a genuine matching. Okay, so the matching could be of the two type. Either the matching is a genuine matching when I'm matching the two similar peoples, or it could be the imposter one. About the score also, you can see that if I'm going to match the same persons, the score, let's assume that the score for if the two peoples are the same person, if the two images are of the same person, the score is higher. Let's assume that it is a similarity, how similar they are. Let's assume that score is such that how similar they are. So if the images are coming from the same person, then the score would be higher. If the images of the two different people, the score would be lower as compared to the genuine one. So if I see the genuine and imposter scores, and the matcher that is going to give me the score is a similarity score, then the values of the genuine matches are going to be higher. Are you able to see that? Yes, yes or no? Once again, what is the similarity and dissimilarity? When two items I am going to match, if they are of the same person, then the score is high if I want to find out the similarity, because they are very similar. But if the score matrix is a dissimilarity matrix, so if it is a dissimilarity matrix, so same peoples are not dissimilar, so then the value would be lower. Okay, same person's things are not dissimilar, then the value would be lower. So what is the dissimilarity measure? Okay, you know that into the Euclidean distance, if 2 points are here, the value would be lesser. Okay, if two person are away, then this value is going to be higher. So similar peoples have the smaller distances. So it is a distance. So therefore it is a Euclidean distance is a dissimilarity. So the value should be lower. Same peoples have the lower value. Okay. All right. So let me give you something like this, that there is a strategy called one versus all, one versus rest. Okay, it means that if you want to evaluate a system, then you match this image with all other image, because matching this image with this image is actually useless task. Okay, it's a bad thing, it doesn't make any sense. You match this image with this, and then this, then systematically with all other. Okay, I have a question. How many peoples I have? 1, 2, 3, 4. 1, 2, 3, 4, 5 peoples. How many images each of them has? 5. How total number of images are 25. If I pick any item, how many scores I would have? Can you tell me? Can anybody type? How many score I would have? 24. Correct. I would have 24 because same I'm not going to match with myself, different values. This 24 is going to be how many genuine matches would be there? 4. And how many imposters would be there? Because when the images match with these one, it is going to be genuine. Okay, these matchings, when this image is going to be match with these things, it is going to be genuine, and all other these matchings are going to be imposters. So how many imposter matchings are there? 20. So 20 plus 24. So this is how matching are going to be. And let me just quickly ask that how many total number of matchings are possible. So since 25 images are there, each of them can be matched with the 24 ways. So total number of matching are 25 multiplied by 24. These many matchings are possible. Once again, this particular number is very large, and it may be possible that if when you are matching this thing with this, well, then this would also be matched with this. So A can be matched with the B, and B can also be matched with the A. Both the matchings would be there. Now I have a question. What do you think that whether these two values are going to be same if you match A with B and B with A? It would be same or not? It would be same? It must be same. Okay. No, actually, answer is actually counterintuitive. The answer is actually no. That it may not be the thing. Okay. A and B and A may not be same. You may be asking that it is not compulsory. Okay, it could be possible that we can make the system in such a way so that A, B and B, A are same, but it is not compulsory. It may be possible that in many cases A, B and B are not same. For example, if I have a face image over here and another face image over here, so if I match this face with this face and I match this face with this face, let me tell you that why there is a problem. Okay, so let's assume that I somehow find out 20 points which I wanted to match here. Okay, but in this image only 10 points are there. Only 10 points are there. Okay, let's assume in the second image somehow I was able to only find out 10 images. So what is the matching? And let's assume all of them are matching. So out of 20, how much are matching? So the score is 0.5. But if I do the reverse one, how many points are there? 10 points are there. I am matching over here. Here there are 20 points, but all of the 10 points which I am going to match, they are going to be matching to the second image. So the score becomes 1. Are you able to get it? Yes or no? Sushant? Sushant, are you able to get that?
Sir, I have a doubt.
Okay.
Yeah,
Please
so
ask me.
so by 10 pixels, you mean the resolutions of both images are different?
Uh, I just wanted to tell you that right now, okay, we are talking on some higher level. Okay, I'm not describing the things right now. So they may be the I mentioned that whenever I match two images or anything, we are interested into the features. Okay, image or any kind of matching generally don't happens with the actual data. So every time you have to find out the feature. What are
Um,
those features? Feature may be the corner point. Okay, and most of the time they could be corner point and their descriptors. So there is some higher level description of the image.
Sir, in
Understand?
that case, in
Hmm.
if a same model is used and the inputs are reversed, then the same number of features would be learned, right?
Correct. But it is not going to be the case because who is telling you that both the images are taken into the same conditions? If the
Okay.
images are taken into the same condition, then you are perfectly fine. But for example, if I take your image in the daylight and I take your image at the night time, whether the images would be same, maybe I would not be able to see your eyes
Mm-hmm.
because I have taken the image in the night. But at the daytime, I can see everything clearly. Understand? So even if it is a genuine match, the features which actually I am looking for may not be available, and maybe that many number of features may not be available. Does it make sense?
Yes, sir.
So we would go to the specific examples when these problems we would discuss into the more detail into the later classes. These things would come once again. Okay. Right now, I just wanted to tell that I wanted to find out the features, and these features point may differ when I'm going to take the different images or different data of the same person. For example, you can see this. Let me tell you this. Just compare this and this. Okay. Can you compare these two images? Just see. This was just a puppet that I have taken the photograph. Okay, just see here. You can see that there is some mustache, but whether mustache is here also, less points are there. So there would be some variations, because otherwise why I'm going to match these things. Okay, these kind of conditions are going to be. So from very high level perspective, what we can say that mostly that's why I just said you with a caution that most of the cases AB and BA are not going to be the same. But some cases it is possible, because I can make the system in such a way so that it take AB and BA and then come up whatever the maximum or whatever the minimum value, then definitely I cannot do anything. So you understood that what is the matching. So once again, I'm not going to talk about the specific matching method. So all those things would come later in the course, and we would see that what are the different kind of feature extractor that can do the things better. So you understand, everybody understood that what is the similarity and dissimilarity scores. Similarity, how much similar they are. Dissimilarity, how much dissimilar they are. If the same person's image I'm going to take, the similarity would be high and dissimilarity would be low. Genuine and imposter, you understood that when I'm going to make the same match the same person's image, then it is this matching is called genuine matching. Otherwise it is going to be imposter matching. You also understood that 25 multiplied by 24 number of matchings are possible. So I have created this particular table. Just focus on this particular table. So this is the first person's first image is matched with the first person's second image. So this image is going to be matched with this image. And it is a genuine match. You know that genuine imposter. This line is going to say the genuine imposter. This is a genuine match. And therefore, let's assume that some method has given a score 0.82. I'm not going to into that detail. 1 1 is matched with the 1 3, and then it is matched with this. The score is this. This way is going to be matched with this. The score is this. 3 2 is matched with the 2 4. 3 2 is matched with the what? 2 4. This match. So this match, and you can see that it is a imposter one. Everybody okay? It is a imposter one because two different people's images being matched, and the score is 0.32. By this I can create this particular table. And this table has 25 multiplied by 24 entries. Everybody okay with that? Yes or no? Can anybody write yes? Great. Now I can divide this table into two tables, genuine table and imposter table, into the separate one. What is the genuine table? Places where there is one. So I collect those places. I take this, I take these rows, I take these rows, I take these rows, and I put it somewhere, and I called it is a genuine matching. These scores are going to be placed into another file. So from one file I have created two files, genuine and imposter. I have created two files. This concept is clear to everybody? Yes or no? I can segregate this file into two things. Okay. Yes. Okay. Can anybody write yes? Okay. So, okay, I have created, then I can divide this into the genuine and imposter one. Let me just focus on the genuine one. So genuine one would have that this is matched with this, and this is the score, this is the score, this is the score. If I pick any score, let's assume 0.5, can I find out that what is the probability of this particular score? What is the probability of this particular score? Okay, can I ask like this, what is the probability? So how can I find out the probability? You count that how many scores are there, and then count that how many times 0.5 is coming. You divide this by this summation, how many entries are there. By this you can find out what is the probability of different scores. Once again, on one side I can plot that what is a score, and another side I can plot that what is the probability. Can I plot like this? Yes or no? Just tell me that yes or no. I would go much detail in more. Can you write yes or no? Yes. Okay. There is something is written by Sushant. Sir, sometime comparing the same pose by two different identities might result in predicting the genuine matching. Once again, if the two genuine and imposter means what? Please be sure. Let me tell you once again what is the genuine and matching. If you know that the matching is being performed between the images of the same person or the data of the same person, then it is a genuine matching. Otherwise, it is a imposter matching. This is the definition of genuine and imposter only. I'm not talking about the score right now. A score could be higher or lower. For the same people's score could be lower, and of different people the score may be higher. We agree with that. You'd come back to this very soon. Okay. So whether this part is clear? Whether this part is clear that I was telling that I'm going to plot the score in one side and probability into the another side. This part is clear? Yes or no? Great. So you know that two tables I had. Okay. This is supervised learning when. So yes, whatever I'm telling, please read on that. Okay. These journal would come and I would introduce at the right time. Okay. Don't get into that. Just understand what I'm telling. Okay. All the things would come and I would teach. Okay. Don't bring new things. And if you have any confusion with my things that I'm telling, please ask. You're most welcome. All right. So few minutes back, I have talked to you that I have created two tables, genuine and imposter. And pick any of the table. On with that table, you can create the one side that what is the score, and another side what is the probability. If I put the probability and the matching score, and let's assume genuine matching score curve is going to be this. Okay. So and similarly, I can find out the what is the imposter's matching score. Okay, probability of imposter matching score. These two curves I can draw. Okay, whether this curve is clear to everybody, yes or no. So you can see why I have put the Gaussian like thing. So most of the time, you know that all the natural phenomena, because we are picking the scores from the very large pool and we think that things are going to be normally distributed. So that's why I'm going to put like this. Most of the time, it would not be exactly normal distribution, but we can roughly think that it is that we can roughly expect that it is going to be normally distributed. So and you can also see that this is the genuine, and here we are going to talk about the similarity scores only. We are going to talk about the similarity scores only. So if it is a similarity score, genuine is curve is going to be this and imposter curve is going to be this. Because we know now when we are going to when you are matching imposter things, score would be lesser as compared to the when you are matching the same people. So that's why the peak is at the higher value and here the peak is at the lower value. Okay. All right. So if you understand this thing, then you can then if I give you two images, for example, image 1 and image 2, and I give you that what is the matching score between them, let's 0.82, and I ask you whether these two images are of the same person or not. Can you tell me? There is no other way that you are going to use a threshold to decide that, because you know that maybe if the score is greater than 6, you can say that if it is greater than 0.6, then I would say that it is going to be the genuine, means these two peoples are same, otherwise they are not. So there is no other way except to use a threshold. So I can use a threshold. For example, I should not draw here. So for example, if I use this particular threshold, because it says score, na, I use this particular threshold. So if it is 0.6, so anything if it is greater than 0.6, I can say that they are actually being matched with this same thing. Otherwise, they are of the different peoples. Makes sense? I have to utilize a threshold. You understand that why I have to utilize a threshold. So if I have to utilize a threshold, so focus on this particular score value. This value, these many peoples have, these many imposters also have this score. So people's whose score is this, because it has a probability that is not zero, these peoples are going to be accepted, because if they come and say some, these peoples would be accepted to the system, because their score is actually greater than the threshold. These people would be accepted into the system. They would be treated as a genuine, same people. They would be accepted. Are you able to see? But it is a false acceptance. It is a wrong thing, because they are the imposter people whose score is larger. They are falsely accepted people. In the same way, if I see this particular score, Okay, you can see that this score, this genuine people also have this score, and it is less than the threshold. So these peoples who have this matchings which have this much score, they are also rejected. So this case is rejected one, they are rejected, but it is false rejected because they were genuine but they are rejected. So two kind of errors can happen. We have to use a threshold to go ahead with the system, but when we are going to use the system, two kind of error can happen: false acceptance and false rejection. Two kind of errors could happen. So in technically there they have the name. This false acceptance is called the T1 type 1 error, and this is called the type 2 error. And if I ask you that which particular error is more dangerous for us, so you would tell to me, sir, this type 1 is more dangerous because they are the wrong people. They are actually they are getting access of the system. Wrong people getting the access. They are what they are going to do. We don't know. They can destroy the system. So this is the most problematic thing. However, this is also problematic when the genuine person is coming to the system and he is not going to get the access of the system. False rejection is also a problem, but these are the genuine people. They, if they are not getting access, they can go for the second attempt. Huh? For example, when sometime when you are in front of your camera and your system is not, your phone is not switching on, so not unlocking, then you can go into the different place, into the mode lighting, so he can go for the second attempt. So it would be nice that if you can it would be nice that to go for the second attempt as compared to allowing these false accepted people into the system. So what we want, this value should be lesser. How can we do that? Very easy. Keep the threshold like this. If you shift the threshold over here, so only this many people would be accepted, falsely accepted, but these many people would have, now they are weeping. A real very less people were having the problem. Now many people are going not able to enter to the system. So you can see that there is a trade-off when you are going to set up the threshold. There is a trade-off. Make sense? Make sense? Any questions on that? Depends upon the hypothesis. Okay, so Abhijit sir is writing that it depends upon the hypothesis. Once again, everything is right now we are not talking about the hypothesis. Let's assume the hypothesis is fixed, but for any hypothesis, this condition is going to come. All right, so let us continue our discussion. So any questions on that? Okay, so we have seen that false acceptance and false rejection are going to happen, and because of this, we would be having some kind of issues with the system. So generally what we want, if you want to be better system, it should be the score histogram should be like this. So having this kind of score histogram is actually this is we want. How to do that? We would see that every time you would be able to do that. I'm not sure about that. Now let me tell you once again. Once again, please be with me. This is the threshold that I'm going to use. On this threshold, I can find out that what is the false acceptance rate. Okay, because you know that what is the false acceptance false acceptance, you know that how many total things are there possible there, so you can divide and find out that what is the rate also. So if I ask you that what is the false acceptance rate, FAR, false acceptance rate, and what is the false rejection rate on this threshold, so you can say that false acceptance is this part, maybe I'm not sure about. Let's assume that it is 30. Okay, false acceptance rate, and false rejection is this particular part, so I'm not sure. Let's assume that this could be 22. I am going to ask a simple question from you, that if I increase this threshold to here, I change this threshold to here, okay, what is going to happen? My false rejection is false rejection is going to increase. It is going to be 45. False acceptance is going to be 25. It is going to reduce. It is something going to happen like this. Somebody is asking, sir, can the threshold be in between less than X and greater than Y? Acha, okay. So the threshold, no. Threshold is only single value. Okay. Threshold means if you cross the threshold or not. Band is not like that threshold, because it's something more greater than this thing. What is the problem? Threshold cannot be a band. Okay. Threshold would be a single value. Any questions on that? Yeah. Is it fine whether this false acceptance and false rejection values are fine to you? Okay. So okay, if I change further the threshold, this 25 can become what? 0. So this 25 can still can become 0. I'm not sure about the false. It could be maybe 88. Similarly, if I change this threshold over here, this value which was 30 becomes 90, then becomes 85. It can increase also. Similarly, this value could also change. Why I'm telling you? Because I wanted to tell you that nearly for all values of false rejection, I can find out what is the value of false acceptance, or vice versa. I can say that for every false acceptance rate, I can find out that what is the false rejection rate by changing what threshold. Okay, I can find out that what is the value of false acceptance rate for a given false rejection rate. Can I find like this? If I can find like this, I can draw another curve where one side there is false acceptance rate and another side there is a false rejection rate. I can draw a curve between these false acceptance and false rejection rate. This curve has a very specific name that is called the receiver operating characteristic ROC curve, and it looks like it would be a single line like this. Okay, so this and every line actually represent about a matcher, because what is the probability of that hypothesis function or the matcher. If you have a matcher, for that particular matcher with respect to the database, you can draw this particular line. It is called the ROC curve, receiver operating curve. You know that false acceptance and false rejection both are the bad things to happen. So therefore, if you see that what is the area beside this is actually represent that how much error it correspond to the how much error I have. Sometimes this also have a technical name called area under curve AUC, and we want this value to be lesser. Let's assume that I have a matcher A. I have a matcher A for which this is what the curve, and I have another matcher B for which this is the curve. So which matcher is better? If I ask you which matcher is better, you can tell, sir, I would find out that what is the area. For the second one, the area is going to be this. So I would find out which has the lesser area, and I can declare that this one is the better one. Okay, make sense? So let me go back to this thing and I tell one more thing to you. I just forget to mention that particular thing. So let me just quickly add one more thing that is a very also important point. So based on this particular threshold, I wanted to tell that sometime for the high security systems, you want that no wrong people should enter to the system. So I want to reduce this thing, so I increase the threshold in such a way so that very less thing are possible, or no things are possible. Very high security places, we keep the threshold very high, but somewhere where there is a less security requirement, for example into the mall, etc., if you deploy a security system in front of your mall, and anybody is coming to your mall and you are telling that you are not allowed, then actually you are losing the business. Most of the time you want to reduce this threshold so that no genuine person should be uh, told to go away. But if somebody bad him have interest to the system, it is fine, we would take care of that, how to deal with that. There would be some other security persons inside, they can take care of that. So threshold can be adjusted based on your security requirement. That also I wanted to tell you. All right. So two systems that I have right now, I was talking about. If you want to match and find out that which system is better, you want to see that you can see that what is the area under curve and tell me that which is better. There is another very important parameter that can also classify, that can also tell you the same thing, and that actually says that can you find out that particular point whether false acceptance and false rejection are same, maybe on this particular threshold. This area and this area, I think this area not same. So I'm not good into the, because you know that if I draw like this, na, I draw like this area and this area is not going to be the same. So looks like that I should take it. Okay. So this gives me the idea that I should draw the threshold here somewhere here. Okay. So that this area and this area is now same. Okay. So this is a threshold where false acceptance and false rejection are same. So this is a very good actually point that tells that peoples are equally have problem, means the false peoples are also getting this with the equal percentage accepted, and the right people are also rejected with the same kind of rate. So this is the better threshold. So people sometimes talk that this is the better threshold. Understand? This particular threshold, the operating point with respect to this particular threshold means, see, you know that at this particular threshold, false acceptance and false rejection are same. False acceptance and false rejection rate are same. So if I pick this particular value, I can say that it is equal error rate. I can say that this is equal error rate. So with respect to the matchers also, I can find out equal error rate. So this is the point where false acceptance and false rejection are the same. So I can draw a line like this. I can find out. So equal error rate of the matcher A is this, and matcher B is this equal error rate. So what is the value of equal error rate? You can see that this value is the matcher 1 and this value is the matcher 2. This is for A1, A, and this is for B, matcher A and B. So since again this is also a error thing, so equal error rate should be lower. The system having the lower equal error rate is going to be the better. Can you tell me which is the better system right now? Can you type? Based on the equal error rate, if multiple systems are shown to you, you can find out that which system is better. Definitely system A is better because it has this much of the equal error rate. However, the system B has this much equal error rate. The system having the lower error rate are going to be the better thing, equal error rate. All right. However, few minutes back we have talked about that. Few minutes back I have also told you that based on your requirement, because false acceptance here is a false acceptance rate. So if it is a high security system, you want to have the false acceptance rate to be lower. So you should operate, let's assume that you should operate on this particular threshold only. So do you afford this much false acceptance rate? Maybe not, if it is a security one, a more high security thing. So you say that I would operate on this particular false acceptance rate. So if you draw like this, you can see that these two curves, which curve is lower, which curve had low false rejection rate? You can see that the matcher A. You say that matcher A is better. So now I'm talking about with respect to your scenarios. If your scenario is a high security scenario, then matcher A is going to be better. But if it is a low security requirement, means you can afford this much of false acceptance rate. So you can say that I can operate on this particular acceptance rate. Then you can choose this particular matcher B because this has the lower false rejection rate. Now you can choose the matcher B. So based on the requirement also, you can choose that which particular matcher you should use. Make sense? Which particular system you should use. Very interestingly, let us use, I would not go teaching you beyond 56. So let us try to see that how much course, how much I can cover. So, okay. Error happens to the system. Okay. Once again, let me give you another simple example. Let's assume that you have a database of the facial images, Mr. A, Mr. B, Mr. C, Mr. D. There are 4 people who have provided you their facial images. In your database, 4 facial images are there, and somebody came to the gate. You don't know that who he is. For example, let's assume that a new person is there on the gate, and somebody has came on the gate. He want to find out who this particular person is. He don't know anybody. So what the guard would do? Guard would use this particular photograph. Guard would use this particular photograph to match against the whatever been pasted, whatever been stored into this particular thing. He find out that what is the similarity. Let's assume that the similarity score he have obtained is like this. For example, here 0.8, here 0.6, here 0.55, here 0.2. Let's assume that these scores he have got. So can you help me that who this particular person is? Who is this particular person is? A. All right, great. This particular person is A. So some image I got, some person's image I got, and if I arrange the scores, I got the highest score is going to be found with respect to the A. I can say that he is A. Next day, some other person has come. some other person has come. I have arranged their scores in this particular and the score with this particular order. Who is that particular person? Who is that particular person? B. He is B. Okay, he is B. Next day, another image. This was the sequence. Who is that particular person? C. Next day, one more image. This is another. This is the sequence. Who is that particular person? He is D. Let's assume that if he was not C, he was A. Then there was an identification error, because I have A can enter as a C to my system. Okay, so this is a problem. But let's assume that every time A, B, and C and D has actually came. So every time my system was correct. Do you agree with me that every time my system was correct? Every time my system was correct? Yes or no? Every time my system was correct. If A, B, C, D actually have come, my system was correct. Yes or no? Yes. So correct recognition of my system is 100%. What is correct recognition rate? Correct recognition rate, that when, in how many places the same person's image is coming at the top. This is the correct recognition rate. Okay, but can I tell that he is B, or he is C, or he is D? Because the image has come at the top, but whether his score should also be greater than a threshold, no? Then only I would say that he is the same person or not. So if I use this particular threshold to decide that whether they are going to be the same person or not, then this score is actually below that particular threshold. Therefore, this person would be rejected. He would not be able to enter to the system. Similarly, however, if this is coming and he say that I am A, his score would be greater than this particular threshold, and therefore he can enter as a system as a. So, however, this particular system has a correct recognition rate of 100%, but there are false rejection rate. False rejection rate means how many genuine I am matching. 1, 2, 3, 4. Out of them, you can see that one has actually failed. So false rejection rate, he is falsely rejected. What is false rejection rate? 25%. Similarly, false acceptance rate, this is the false acceptance person. And how many total number of genuine imposter matchings we have performed? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Out of 12, one has actually succeeded. So 1 upon 12, it is going to be 8.3%. What is equal error rate? With respect to the different threshold, you have to find out that what is the false acceptance and false rejection, and then you have to plot the curve, and then you have to get this particular line and report me that what is the value that is actually going to be same, equal error rate. This is how you find out this. Okay. Our objective when we are actually training the system is going to be to reduce the misclassification thing. What is the misclassification? If the item is of the of type R1, but you classify it as a R2, or the item is of the type R2 and you classify it as a R1 class 1, then this is going to be mistakes. So you can define the probability of these quantities, and you can as well write a integral equation sometime in a fancy way to represent the same thing. Your objective would be to reduce this kind of errors. And before going any further, I just wanted to tell this particular very important slide also, that when you are going to make a system, only running behind the higher accuracy is not. Accuracy means at how many places both are going to be the same, is not only going to be our sole concern. Sometimes this is not a good idea. Only running on the behind the accuracy to be a good idea. Let me give you an example that would make the things clear. So let us define, let us build a classifier for the terrorist trying to board the flight. The problem is this, that let's assume that you have a aeroplane, and you are going to develop a system, this system that you are going to develop, where in front of this thing multiple peoples are going to come. If your system is going to say that he is terrorist, he would not be able to allowed to enter to the flight, otherwise he would be able to allowed. Your system is going to identify whether the person, whatever information you want to use, you are going to use this thing and you are going to tell that yes or no. Okay, you are going to allowed or not allowed. So this is a complex system. You know that this is not a easy system, but I can give you a very, everybody okay with that definition? Are you able to understand that what I wanted to make? I wanted to make a model that given a person can tell me that whether the person is terrorist or not, so that I can refrain him in going inside the aeroplane. Problem is clear? Yes? Nobody is writing yes. Okay. Okay. So you know that this kind of system is very difficult to make, but let me give you a very simple example. And let me say that my system has accuracy of 99.99%. And I claim that it is so simple that you can compute it in your head. I'm going to tell you a very simple thing. Predict that no one is terrorist. It gives very less error. Correct, Sushant, you are correct, absolutely right. So I am going to, the model that I'm going to give you is this, that my classifier is going to tell no to everybody. And the matter of fact is this, that 800 million average number of passengers in the US flight per year. Okay, out of them only 19 were confirmed terrorists who boarded the US flight from 2000 to 2017. So if you say no to everybody, your accuracy would be 99.999999%. Such a good system. But would you like to use this system? Definitely the answer is no. You cannot neglect which side the error is. Okay, where is the error? You must consider that particular part also. So a few more things that we wanted to discuss in today's class, but I think we can very quickly cover this into the next class. So I think we should stop at this particular point. Thank you joining. Thank you for joining. We'll continue our discussion from here henceforward into the next class. Thank you very much. Thank you.